Yeah, hi. So I'll be talking about something, I'm not sure if it will be very interesting for a lot of you folks, but if you guys have worked on, so I guess everyone is an Android developer, anyone who is not an Android developer? Great. So this content is generally a little bit generic, I would say. It doesn't only focus on Android. So I hope that you guys drive some sort of engagement and knowledge from it. Cool. So so I will be covering most of Android stuff only. But before I begin, I just wanted to know how many of you guys work in an environment where you have inherited a code base, like you joined and it was already an app that was live for the last maybe 5, 6, 7, 8, 10 years. How many of you? Oh, okay. Great, then I think it will be relatable for a lot of you folks. I was afraid maybe all startup folks and then, oh, I created everything from scratch, so I don't know what you're talking about, but okay, cool. And also, before I start blabbering with my slides, I just wanted, so I will be interacting a little bit with you guys, right? And I want all of you guys to speak up, okay? Like it doesn't have to be, I don't want formal answers from people, but just speak up, like one-liner, two-liner, whatever, okay? See, if I ask you to describe what a legacy code base is, any one of you, like a single liner, one word, what do you think a legacy code base is? Is it just old code, like anyone, like whatever you can think of, top of your mind?
Activity with 3,000 lines of code.
Great. Anything from a general programming perspective, anyone? Go ahead.
Of multiple technologies.
Cool, yes, that counts. Anyone? Sorry?
Structured old starter code.
Okay.
Android app in Java.
Okay, cool, yeah. All right.
Find view by ID.
Oh, yeah, that also counts. Find view by ID.
Deprecated libraries.
Okay, cool. Oh, all right, okay. Cool, so we will be debunking some of the myths of what a legacy codebase is. And once we understand what a legacy codebase is, we will be moving forward to knowing how do we work with legacy codebase, okay? Like what is our next steps? Like how do we go ahead with it is what this presentation is all about. Because at the end of the day, we do not control the environment. I mean, we joined a company that has a 10-year-old codebase and we have to work through it, we have to grow it, we have to ensure that it does its work, right? So the main goal is how do we move ahead with it, right? Cool. So I hope the down button changes the slide. If it doesn't, then you have to give me some time to figure that out. Oh, wow, fantastic. Okay, cool. So yeah, you can read through the pointers, but I wouldn't be talking with the pointers. So this will just be there on the background and I will be blabbering my own stuff that comes to my mind. So bear with me, please. So I will be describing what a legacy codebase is. This has got nothing to do with Android, and it would be maybe validating some of your, whatever you guys said, maybe validating some of your points, maybe contradicting some of your points, right? So technically it serves the purpose, okay? So you have a large code base and maybe it's old code, maybe it's Java code, maybe it's whatever there is, but it does the job, okay? The app still runs, you're able to maybe show a page that you are supposed to render and somehow things work, but the point is you do not know how it works, okay? So that is one of the things, okay? And also the other point in here is you do not have people to go to, like there were some people who made the code, but then they are not in the organization anymore. So you do not have anyone to go to and ask, hey, why did you do this? Why did you do that, right? So no key decision makers, no one to ask why the design is like that, like this. So you are the captain of your ship, and if you mess it up, okay, it's on you. It's kind of like that, right? And also there is this overwhelming feeling that you get that when you look at the code, you feel like if someone gave me a chance to rewrite it, maybe I would be doing a much better job than trying to modify or extend the code, because if I modify or extend the code, I do not understand what is happening, right? So you have this urge to rewrite it completely and you feel that this would be better, but then again we will be talking about why it is difficult to rewrite such a code. And obviously the code does not have unit testing and it has no documentation, because if it did, then you would have known what the code is doing and it wouldn't be that difficult or fearful of you to work on it, right? Cool. So now we will be talking about how does legacy code look for an Android application, okay? So I think some of you mentioned that activity with 3,000 lines of code. So yeah, definitely. God activities, God manager classes, which has unlimited lines of code, and some part of it works, some part of it doesn't work. You do not know who is calling what. Maybe some of the functions are not accessed. It's very difficult to figure out, right? And also activities doing everything. There is no use cases, no demarcations whatsoever, right? Then there are anti-patterns. So some of you talked about find view by ID, maybe hard coding of resources, maybe the string is hard coded into an XML. So once you change the buy now button, it doesn't change anywhere else. So we'll refer them as anti-patterns. There are abrupt and random utility classes lying all around. There's a time utility, there's a currency utility, there is any utility that you can think of, maybe calendar utility, whatever, like thousands of things that utility class has, static methods. Some are used, you do not know what it does, how it works, but people are just randomly using it. A lot of view binding classes. So how many of you have used data binding on production? Cool, so you know how difficult it is to deal with data binding after some point, because it becomes quite difficult because people start creating adapters as they want, and it becomes very difficult for new people to understand what it does, right? So obviously those are there. Then singleton classes, static classes to save session data, using it randomly at places, updating the data from random places, right? Very difficult to track, figure out. Callbacks. How many of you are frustrated with callbacks? Raise your hands. Yeah. It's very difficult to deal with callbacks, anonymous callbacks. You do not track the variables that are responsible for holding the reference, and then you are not clearing it. Memory leaks, it's a nightmare, right? And obviously, if you guys have not come through this kind of code, there are also callbacks inside callbacks, so that's more horrible. And then obviously, there were no concurrency back in the time. I mean, there was no structured concurrency back in the time, like coroutine. So there were thread.new, handlers, RxJava, all. Async tasks, maybe if some of you have worked with async tasks, you would know it's horrible, right? So there are a lot of things that, contributes to all these things. But the point here is, not all old code is legacy code, okay? It's code that you can't predict, you can't work with, and code that's really difficult to understand and, give output with. That is what legacy code is. It doesn't mean it's a 10-year-old code base, but which is like unit tested correctly. Maybe the technology is still alive, still there are concepts that hasn't changed. Doesn't count for legacy code. It's more about unpredictability, more about not understanding how things work. You are not sure how your changes will reflect. That is the difficult part to deal with, okay? Cool. So, what are the problems with legacy code, okay? So definitely these are the theoretical problems with legacy code. So it's very difficult to integrate new features. So you are working on a code base, and then what happens is someone comes to you and tells, okay, you know what, we need this new feature, we need this new page. But the thing is, this new page also, say, uses something that is already there in the class, or already there in your application, right? There could be some front-end logic that is there. It's quite complicated for, say, to move it to the backend, and hence it exists on your application, and you have to somehow use that logic, right? You do not exactly understand how that logic works. So it's very difficult because you have to integrate it to the new feature. You have to know that this new feature works. So adaptability is definitely a problem. Then there is cost, right? The cost is about people. So there are like maybe 5 people, 6 people working on a feature, and then you are taking time to ship it because you do not exactly know how it works, and you are making code changes. Sometimes it works, sometimes it doesn't work. So that takes up a lot of time. Performance could be a problem with older code bases. Then the famous problem with scalability. So how many of you guys know what a scalability is from a mobile app perspective? Okay, it's a little bit different from backend. So we have a talk scheduled later today for scalability, so we will hopefully get a detailed version of it. But very briefly, just to just connect the dots, I'm going to just speak what it means in this context. So it's more about using, having a piece of code that uniformly behaves across multiple Android devices, okay? That will be a very generic definition of scalability. From a mobile perspective, of course, it has different definitions. And so what it happens is in some of the phones, maybe not in some of the phones, as in not in some devices, but maybe in some scenarios, there is a feature that works absolutely very well, but Similarly, you can see in a different circumstance it doesn't work. It could be a concurrency problem, you do not know, it could be a lot of problems, but it does not behave uniformly across devices, right? So this is what I refer to when I mean scalability. And obviously there could be security, there could be compliances, maybe people have hard-coded keys in the older code, whatever. So it just get exposed when you maybe unzip the APK and see. But let's talk about the real life problems, okay? So the real life problems from a developer's perspective. So when it comes to us, when we are writing the code, right? What problems? So those are the theoretical problems, right? So it takes a lot of time for us to make the changes because we completely do not understand what we are doing. The code is not predictable, so we think that something is going to work, but then when we make the changes, it's not working the way we expected it to work. There are unrelated side effects, so you change at some point and then you maybe realize that it completely broke in some other part of the app. And whenever you are making those changes, you are constantly adding to more tech debts because you are not doing anything about it, you are just making things worse than it was, right? And what does it mean for a company? What does it mean for an organization, right, who is employing you? It means that they are not able to ship features when they want to, right? And it's very difficult to onboard new people. So someone joining your team will need some time to understand what you are doing and how that person can contribute to it. So that's a big problem for a team, especially who is responsible for delivering things. So what do we want? Like, what do all of us want as developers, right? We want to write good code, right? We want to write code that works. We want to write code that's predictable, that's testable. And we want to solve awesome problems, right? That is why we are engineers. That is what we want to do, right? I hope everyone wants to do that. Okay, cool. And this is what we want to do, right? This is what we want to actually do. So how do we go around this? Because we are not controlling the environment, right? We inherited that code base. Nothing we can do about it, right? But we can make things better. So first, we change our mindset, how we work. That is the first thing that we do. Second, we document the things that are already there. Third, we try to change things for the better. We refactor the code. But all of this depends on what the business needs, because at the end, technology just enhances, it's just a translation for a business requirement, right? That is what tech does anyway. Cool. So we talk about mindset. So we question, why were things written like this? How many of you have written bad code in your life? Okay, everyone has written bad code. Did we intend to write bad code? Did you think, oh my God, let me write some bad code. This is what I want to do. We did not, right? But somehow we did end up writing bad code. We realized it later down the line. So the point here is, there were a reason why the code is like this. No one thought one fine day, wake up in the morning, today I'm going to write bad code. I'm going to write static classes and I'm going to put the variables right here and there. So that 5 years down the line, they're going to remember my name when they annotate the gate. So no one does that, right? So there must be a reason why things happened, right? And one of the primary reasons from my experience is that you have to deliver something in a very short amount of time, right? And what happens is, there's no one to support you. Like, for example, no one is going to come to you and tell you, I understand the engineer's pain. You write good code, I'm going to talk to management and add like 30 days to it. Right? They're going to tell you, okay, I understand, maybe take 2 minutes and maybe give it to me by 4:30. Cool? And then you have to deliver things, right? So what do? You make things work. So the primary friction point is making things work. And depending on your experience, on your expertise, people end up doing a lot of things, right? As you grow more experience, you understand these patterns, you avoid them, you become better. But when you did not have that experience, when you did not understand what you were doing, you basically end up not doing great things, right? So you understand why the code was written that way, right? Maybe it could have been maybe they were solving business use cases that just worked that way. Maybe there was a reason to do that. Whatever that is, you just get just believe in something. Like maybe they needed to deliver fast. Maybe they needed to make things as fast as possible, right? Cool. For us all who are working in an existing system, it's an opportunity for us every day to improve what is there. So that should be a motivation, a goal for us to write good code, okay? The best thing out of it is, when you develop a new feature, you think in a very large scale, okay? I'm going to do this, I'm going to make new classes, I'm going to build a new framework, I'm going to work on this new architecture, this design pattern. When you work with older code, you think small. If I change this method name, if I change this variable name, 10 people after me can understand it easily what it took me 1 hour to understand. So count small, enjoy those small moments, because even if you make small changes, that matters. Maybe add a line of documentation, maybe there is a complex if statement, maybe make that simpler, okay? So that it helps other people. So make those small things count. That's one of the best things that you can get out of it. If something breaks because you made a change, it's okay, because you did not write the code. It's not possible for you to go through 3,000 lines of code and understand things, so it's okay. And also your team members are not stupid. If they have broken something, maybe they did not understand it fully. So stop blaming people and calling people stupid. Maybe if you were there in their place, you would have made the same mistake. So the second point was document. So how do you document things, right? It's very simple. So you see a class, a method. If you can understand what it does, maybe write a comment about it, okay? You can add module readmes. Everyone is using Cursor or Gemini with Android Studio, right? You can generate module readmes, maybe read through the readme and see if it makes sense. If you know some part of it, maybe append to that readme and ensure that it is kind of updated. So someone who is reading after you can understand. You can definitely make flowcharts if you understand flows, maybe make a Confluence doc out of it. Whatever you can, try to document it. It will help you in the future. It will help other people in the future as well, okay? Small step again. Now I'll talk about the main part, okay? Okay, also I think I did talk about one other thing, okay. So let's talk about the main part, refactoring code. So how many of you guys have refactored code? Cool. I want a very specific, very generic definition of refactoring. One liner, one word, anyone? What does refactoring mean?
Making it better.
Okay.
Simplify it.
Okay.
Efficient.
Making it efficient. Cool, cool.
Upgrading the code but just maintaining the same functionality.
Okay.
Making sure that whatever worked earlier works right now.
Okay.
Breaking code into smaller chunks.
Sorry?
Breaking code into smaller chunks and
Okay.
across various classes.
Okay. Cool. So what do you think is the goal of refactoring? Why would we refactor code?
Understand.
For the understanding purpose.
Sorry?
For the understanding purpose.
For understanding, okay. Any other reasons you can think of? Performance, okay.
Segregating proper responsibilities.
Okay. Okay. Cool. So do you guys think that refactoring only has to be done on older code, or can we do it on a newer code as well?
Newer code as well.
On both.
Sorry?
On both.
On both, okay. Cool, cool. So in here, I think it genetically defines what you guys, I think it's on the right track of things. So I'm not going to talk about refactoring anyway. But I'm going to talk about refactoring in the sense of how would you refactor a legacy code base, okay? Because you have an older class. So in the example that I'm going to, so just to set the context of things, imagine you have a class only for the sake of this slide. The example that I'm setting is you have a class, okay? Let's think about you have a God class, okay? It's not an activity, it's not an Android specific class. It's a manager class, okay? And I'm going to take our example. So we used to have a class that used to have everything related to payments, utilities, okay? It was like a 4,000 line class, and it handled from Google's authorization to wallets and Amazon Pay and everything, okay, in one class, okay. So let's imagine something like that, a 4,000 line of code, multiple classes calling it, okay. If you command and click on a method, you will see like 20 accessors out of it, and there is no dependency injection. Testing is out of the, like, don't even think there is a word called testing. So you do not exactly know. You just know it works, okay? You click on it, Google Pay works. What it does, I don't know, okay? So let's think of something like that, okay? On those lines. So we have something like that. And so how do we go about testing it? So how do we go about refactoring, okay? So let's say I have a requirement, okay? I just told you that I have a class that handles, say, authorization of Amazon, that handles authorization of Google. maybe makes a few API calls and make those transactions possible and just gives you a token saying, okay, this happened with Amazon and your transaction has been successful, happened with Google, your transaction has been successful, okay? And also say that that class has a lot of validations. So when you go ahead with Google Pay, you understand that, okay, there is a need for a UPI ID, maybe we need to validate it and stuff like that, right? Maybe, so if you guys have worked with Google Pay SDK, you would know that Google Pay SDK, depending on certain versions, act differently. So for certain versions, they have different APIs. After certain versions, they have different APIs. So there are like things like that as well. Cool. Say there is a new requirement that came to you, okay? And say that requirement is whenever one of this Google Pay or Amazon Pay transaction happens, you need to call an in-house API which logs certain details so that your organization can track, say, certain metrics out of it, okay? So what you need to do is you have your older code base, you don't need to do nothing, just add this functionality that whenever such kind of authorizations are happening, you are calling an API and you are logging certain details, okay? So keeping this in mind, I'm going to talk about a few points, okay? So there is something, so how many of you have read any article or book about refactoring code? Any one of you heard Michael Feathers? Okay, there's a very good book called Owning Legacy Codebases by him. It's kind of a golden standard for refactoring code. So he has come up with a few terms that I'm going to use. So most of the terms that you see, seams, sprout and wrap are all defined by him. I'm going to talk very briefly about what these things are. So we have a concept, it's called sim. Okay, what does a sim means? It means that you have a program and what you want to do is you want to alter the behavior of a program without changing much of the original code. So you have a manager class and say it uses an object, okay? And what you want to do is you want to alter some behavior, but you do not want to change code in the manager class, okay? So what options do you have? You change code maybe in that object that is of, where you are applying that, right? Maybe there's a payment object. So let's think it's a POJO object. It has certain properties. So the goal here would be I would make certain changes to the implementation. Could be a POJO object, could be polymorphism, could be something say let's consider polymorphism, okay? So you have an implementation that you are supplying. It may change with certain different runtime. You are passing different variables depending on your use case. So what you do is basically you polymorph that, that exact behavior. So how does it work is you identify those areas that are sims. So where can you insert those? For example, if you're an object, okay? Maybe in one of the implementation, you change the way it's supposed to work. Like it's working originally in way A, you make it A dash in one of the extended implementation. Extended implementation could extend either A, which was the original implementation, or it could be a direct polymorphism. It could be an object, it could be an interface that has been extended by an object, and that object you are supplying. So what it does is, because you modified this, you want to see how your behavior in the program changes. And why do you need to identify the sims? Because in your older code base, you do not have dependencies exactly the way you want to. So how many of you have worked with Dagger and you know what a dependency injection is? So do you guys have a basic understanding of why do we do dependency injections? Okay. So one of the use case of dependency injection is we want to make code testable. So if there is a class, we want all the dependencies of that class to be there so that we can check or we can test individual functionality of that class. Okay, so we want all the dependencies there. So we want to know what that class is dependent on, right? And the problem with legacy code base is most of the time is we do not exactly have that bifurcation of dependencies. It might not have dependency injection, it might not have those dependencies injected into it, right? But in order to write a unit test, you would need those dependencies, right? Because how would you otherwise fake something or mock something, right? Hence, you need to identify those sim areas where you can like change certain stuff so that you do not alter the code, but you change the functionality of it, okay? And once you identify that areas, you write characterization tests around it. So what are characterization tests I'm going to discuss? How many of you have worked with unit testing? Okay, integration testing, anyone? Cool. I hope everyone has a very basic idea of what a unit testing is, right? We test units of code, okay? Okay, before I go to what characterization testing is, we mostly do unit testing because we want to test how individually things work, okay? However, in case of legacy code bases, things don't work as you expect it to work, right? Things work because they are written in such a way. So you expect something, but the actual implementation is different. So what character is, so once you discover those sims, you understand what the character is. Then you write characterization test based on it. So what it means is, you test the actual behavior rather than the expected behavior. That is why you identified those sims, okay? So next you write whatever you understand. So you might not know the exact characteristic at that point of time, but whatever you found out, what you understood, you write characterization test for it. So you supply some input and you expect this to be the output. So A, you identified the sim, you wrote a characterization test. Now, if you change something in that bound, you would understand because your test is going to break. So you do not write unit test case, you do not write integration test, you write characterization test, but first you identify the sim, right? The area where you can change without altering the code, okay? So you make things more controllable, you make things more in your favor, right? So once you have written characterization test, you know the expected output, not the actual, you know the actual output, not the expected one, because that's not how refactoring works. That's not how legacy code works. Now, how do you add your own code, right? The example that we discussed is we are going to make an API call that does this instrumentation thing, right? It logs certain things, right? So we are going to talk about two techniques. One is a sprout technique and one is a wrap technique. And if you just literally translate these two techniques to English, what does a sprout mean? That it sprouts somewhere, right? So what essentially a sprout does is, so you have to make an API call. So you make a function in a class. Maybe you can make it in a different class. Maybe you can make it in the same class itself, but I would recommend making it in a different class. You make a function that is independent or not dependent on the older code. It's your own implementation of things, right? And you call that function from an older function, which is part of your legacy code base. So now your new function that you have written is something you control because you have written it, you know what is there, there is no legacy code base, so it's predictable for you. And you are calling that from the older function. You can even write your characterization test around it and you can ensure that things are working as you expect them to work, right? Next is the wrap technique, okay? So what does wrap mean? So wrap is something where what you do is, say you have a function called getXY, okay? And it takes in certain parameters. So what you do is replace this getXY with the same function name, because let's talk about object-oriented programming only because we are talking about Kotlin and Java mostly. So you method override it, and what you basically do is you, instead of calling that older function, you call this new function with maybe the new parameters, okay? Now this older function, this newer function is going to trigger your old function internally, but before and after that function, you can insert your own code. So your older function retains its capability. It's not unpredictable, it was behaving as it would, but your code either resides up or down that function call. So you do not insert in between them. So you kind of have a control over it, right? So these are the two techniques, and again, when you change the code, you run a characterization test, you see what the actual output is. If it matches, maybe it's your good luck. If it doesn't, then yeah, you'll figure things out. So this is a very general way how you can refactor code. And this again depends on a lot of use cases. It varies. Maybe all activities would not work this way, maybe not all use cases would work this way, but there's a very generic theoretical way of making things work, a framework to keep in mind.
But you still have the legacy code in the second technique, right? Because you are just abstracting.
Exactly. So this is how you work with legacy code. You still have that code. This is, say you are supposed to add a new feature. So what we do not want to do is we do not want to modify the old code, because when you modify the old code, you are probably adding to more of tech debt.
This will also add tech debt, right? Because you're adding.
Definitely, this will, yeah. This will, but this is your way to navigate things, because you are not directly modifying things. You are writing your own thing, so you can actually make it more predictable.
I and then slowly start to move that.
Right, exactly. Yes, this is the way you walk through things. This is not the final output of
That
things.
is the most important thing, where you eventually get that code up.
Right, yeah. So this is how you start working with things. This is how you navigate through. Now, obviously, you've got to refactor things. So once you start making things, moving out things, then you increase that scale.
So that you meet your demands also, you meet your requirements.
Exactly.
At the same time, you
Right.
do your refactoring. So I
Right.
think that is better. And
Yeah.
the Sprout technique is, I think, always a better option, right?
I mean, both are kind of good. It depends on the use case,
And your requirements.
on your requirements, yeah.
Also, this will not add breaking changes, right?
Exactly. So idea is you want to make things predictable. That is why you have test, and also you can ensure whatever functionality you are writing, you are adding unit test cases to that. So you know your code how it behaves, and you know the characterization test is also working. So the point is you are able to deliver things. You are not afraid of things. And yes, eventually down the line, there are many ways to refactor the code. I mean, obviously you can start with this tech. These techniques are all for adding code. But then once you start, say, moving a functionality to a new class, you have now different classes. Once this scales up, you can segregate code, and maybe you will have a much better
This
refactored
should allow
code.
us to do that.
Right. So this is more of a practical use case, I would say, that you get in a day-to-day life where you do not actually get 3 months to refactor things. Cool. So to recap, you identify the sims, you break down the dependencies, you write test, make your code changes, and then you refactor finally. This is how you work around things. So after you did all these things, so what do you have now, right? You have something you understand, you have something that you have documented, you have something that you are less afraid of. But we talked about some other thing as well, right? We talked about business needs. So all of you who work in an environment, in a company, all of you knows that we build apps because we want people to use it, right? Because there's business coming out of it, right? That is why we get salaries. If it was only tech, then we would all have been broke because no one cares about coroutines or anything, right? Like people do not walk in the street and think about, oh, this guy used concurrency, let me download this app. No, right? Because it does something, right? Either you're booking a movie or whatever you're doing, right? So it's all about business needs. Now, before you go ahead and start refactoring things, and before you feel that OCD, okay, let me refactor this is bad. First, you have to ask yourself these questions: that do I need to refactor things? Do I really need to change this? Does this have a need? That's the first question, because it's costly. Okay, it's going to cost you your time. It's going to cost your company time. So you have to decide that firmly. Maybe all refactors are not worth it, right? So once you determine that, right, is it good for your business? It's bringing in revenue. Once you determine that, it's good. But also one thing that you have to keep in mind, which is other than this business part, because see, always there's going to be business for all of you who work very directly with business teams. You would know that business doesn't really care about tech, right? They just want things to be done. But the greater question that you need to ask yourself is, if I do make these changes, if I do refactor, does this help me in the future? So if a requirement comes in that class where I need to change, and if I make these changes now, if I incrementally keep making these changes, does it help me in the future? So that is also one of the questions. So it's kind of a balance, but these are the questions you need to ask before you start refactoring things. So what do you do next? Right? So you have refactored code, you have a good code base, you are happy. So how do you proceed ahead with it, okay? We always build with frameworks, okay? Do not reinvent the wheel every time. Whenever you write something, make sure you have associated a framework with it, so you are able to reuse it, your team is able to reuse it, okay? You never write code that is just for this functionality. Whenever you feel like that, maybe extract it someplace more generic, more general, okay? As some of you said that even newer code needs to be refactored. So once you are confident moving around even your newer code, you know that you have actually ticked a lot of boxes. Like you have made sure dependencies are all right, you have unit tested. So once you have things in place, it's very easy to move around code. So keep on moving around code and ensure that you have structured code. Now I'm going to address the elephant in the room, AI and refactoring, okay? Everyone has access to cursor, and it's just one prompt away. In this class, please refactor and make it simple. and it's going to take a prompt in, it's going to refactor, and then all the best to you in finding out if that refactoring has been done correctly. Because I am not sure how many of you guys have experience with this, but the way cursor or maybe maybe if you guys are using yeah, I mean if you're using anthropic models, or if anyone has anyone used GLM? Okay. If anyone has used GLM or any anthropic models, you would know the code looks beautiful. It's documented. When you look at the code, you would feel like, oh my God, I haven't thought of this. You run the code and then you will understand why haven't you thought of it. So, okay. So, is it a one prompt away thing? Probably not. Okay. But how can you go around it? So, obviously AI is a superpower, and I'm pretty sure there are talks after this where we are going to talk about AI. But very briefly speaking, when you have AI, you have this, I would say, this luxury of delegating things, right? You know the method of doing things. So maybe start with a TDD technique. Maybe ask the agent to break code down so that you can write unit testing first, and then maybe ask Gemini to build features from that unit testing. So first you understand what the characteristic of the code is. Maybe ask Gemini to write unit testing from your already written code base. So once that passes, you would know that your unit testing suite works good. Once that is done, you can ask Gemini to probably generate a class using those unit tests that are there, right? Could be one of the ways. You could have better ways to do it, but please do not single prompt it because you wouldn't be able to figure out anything. Cool. So that was from my side. I hope I was of some value today. And thanks for joining. Thanks for listening. Thanks for not sleeping. Cool.